Hey everyone, welcome to the first SQL lecture. Um, as I mentioned yesterday in the Slack channel, you all have built out your projects and you were scraping and you experienced this thing where if you wanted information to exist in your database, right, you needed, or sorry, if you needed information to exist in your application, you would have to continue to scrape over and over and over again every time your application started. The big key that we're missing here in order to make our applications feel more like we're used to experiencing them today is a database. We need our information to persist, right? So this is where we're going to start going today. I'm going to give you an introduction to what's called SQL. SQL is SQL, stands for Structured Query Language, and it's basically the general, most widely accepted, agreed upon way of, or language for querying databases. So in kind of a way that Ruby is a language, SQL exists for the purpose of querying databases. So I have a little bit of some learning goals that I want to go over today. So today we're going to talk about explaining persistence and the need for using SQL, which I kind of just touched on. I just defined SQL a little bit. What is SQL and databases in general? We're going to talk about the difference between SQLite 3 or SQL, or the many versions of SQL that exist. We're going to also talk about something that I don't think I put on here. We'll talk about the difference between relational and non-relational databases. We're going to open up SQLite browser in a database that I already kind of have pre-existing. We're going to play around with that a little bit. We'll talk about the primary key and the foreign key, and then we'll maybe look at we'll observe some examples of relationships that we've made in our applications already. So if you had, an artist has many songs, a song belongs to an artist, we'll see why we have that convention and why that's important in relation to databases. We'll also kind of touch on the single source of truth here. So define a primary key, define a foreign key. This kind of all has to do with single source of truth. We're going to talk about what CRUD is. CRUD is just basically an acronym for what we talk about databases and applications in general do. And then we're going to perform CRUD actions across related tables. Any questions on any of this so far? Sweet. Awesome. Thank you for the thumbs up. Okay. So SQL is kind of one of the earliest technologies that we're going to use. It kind of really became standardized in the 80s. And the reason why we still use it today, it says first appeared 45 years ago. I'm just kind of looking at the Wikipedia page. The reason we still use it today is because it's simple enough and it's effective enough. We haven't really had to change too much of it, right? But it's a domain-specific language. It works specifically with databases, particularly relational databases. So relational databases are databases that kind of look like this. So, let's see where I had it. Okay, cool. So relational databases are databases where there are like several different tables, right? And each table, as we'll see in Ruby, kind of relates to a model. So if you have a model in your Ruby application called tracks, then there's probably going to be a database or a table in your database called tracks. And just like in Ruby, you probably had a bunch of instance variables or attributes. And these kind of translate to what the columns on the database are going to be like. So if you have a track and a track has a name, it belongs to an album, it belongs to a genre, it has a composer, it's got a length of milliseconds, how many bytes, the unit price, for example. These would all be attributes in your Ruby application, in the Ruby model. But you'll see that most of the time, these attributes also relate to the tables that exist on the database. So an album, for example, has a title, it belongs to an artist. And then an artist maybe just has a name as an attribute. And that's maybe the only column that you'll see on the database. Now, relational databases, in Ruby, we may have, for example, associated a track with an instance of an album, for example, or an album with an instance of an artist. But as we'll see once we're diving into databases here, that those instances that we use in Ruby just become references to those instances via what we call a primary key. Primary key on the column itself, and then the foreign key on the in the relating table. And it's okay if you don't understand this 100%, I'll dive into this a little bit more. But to kind of give you an example here, notice how a track or an album, for example, has an artist ID as a reference. So we're no longer, in the database world, we can't relate to another Ruby instance, but instead we'll say, hey, I'm an album, Lemonade by Beyonce, right? And I can't reference the instance of Beyonce here in the database, but I can say, well, if you go to the artists table, I know that Beyonce is artist ID number 55, right? So this is the way that the relational databases are going to start working. There's also such things as non-relational databases, and I'll Slack this resource out later so that you guys can take a look and read about it a little bit. But relational databases, when we imagine them, you can kind of look at them like this, like there's a table and a column on the table might point to a reference on a separate table, right? And through these references to each other, we can create relationships. So relational databases are really good when you have models that are required to interact with each other in a very specific way. This will basically be working completely with relational databases in this project, or in your projects here. Everything in Ruby will be relational databases. Let's see. The kind of benefit of using a relational database, but also its downfall, is this concept of referential integrity. So you'll see, for example, in your application that maybe, if you are creating something like the music library CLI, where you have an artist that has a bunch of songs, well, what would happen if you actually deleted that artist? Should those songs exist without a reference to an artist anywhere? The answer would be no, right? You would have a bunch of songs without something to an artist. So you may have worked in an application before where you were asked to, or let me see if I can think of an example. If you are on Flickr or some kind of photo sharing application and you delete an album, it's going to ask, do you want me to delete all of the photos inside, right? Because there's a relationship here. Each photo belongs to this album. And if the album disappears, then should the photos exist without an album? How should that relationship be handled? So relational databases are really good for these kinds of things, right? If you have a Facebook and you delete your Facebook, the relationships between you and your friends should no longer exist, right? Or if you have a post on Instagram or something and you delete the photo, the comments should no longer be existing in space without a reference, right? Without a photo post that they belong to. So that's kind of really what relational databases are used for. There's also such thing as NoSQL, and there are several people who've gone through Flatiron who now work at what's called MongoDB. And I would say that Mongo is one of the more popular NoSQL databases, and also called a non-relational database. And non-relational databases are really used for when you have a lot of information that you need to handle really quickly, and the relationships between them maybe aren't super important. For example, I had a classmate who was creating an application for iPhone and Android that gave you the next subway arrival time based on your location. And the MTA API, which exists, and that might be something that you look into later, if that sounds like a cool project for you, would bring in thousands and thousands of arrival times for subways, but these arrival times become obsolete within seconds, right? If you have if you get an update and it's like, oh, this, the next train arrives in 30 seconds, well, 1 minute from now, that information is obsolete. So he was dealing with huge amounts of data and just needed to go through them really fast and get rid of them really quickly. A relational database wasn't necessary for him, so he actually used MongoDB, or another one that you can also use is called Redis. So I'm just trying to give you a little bit of an idea of why we use relational databases, but what else might exist, or what else could exist depending on the type of application that you're building. You can create queries to make relationships with NoSQL databases, but it's kind of tricky and not really the best use. But I'll stack out this article so that you can kind of get a little bit of information about why you would want to use one over the other. But again, for the purposes of this program, you should be focused, or will be mostly focused on using relational databases. Jen, did you have anything that you wanted to add to relational versus non-relational databases?
No, I thought that was a really good in-depth overview.
Cool, thank you. Sweet. So I'll save this. What else are we going to cover? Okay. So SQL, again, structured query language, is the language that we use to query databases. And there have been several different interpretations of this. The one that we're going to use today, and the one that you'll be using in your first Ruby projects, is called SQLite 3. SQLite 3, as it sounds, is missing a few queries. I just actually beforehand was practicing some of them and realized that ones didn't exist. But as we get further into the program, we'll be using something called Postgres. PostgreSQL is, or Postgres, I don't know. I always feel conflicted about exactly how to say it. But it's a little bit more advanced, and it's more product ready. So at the beginning, when we're making these really simple applications while you're practicing, SQLite 3 is just going to be kind of the go-to. It's built into Sinatra or Active Record in Rails, and this will just kind of be the default that your applications go to. But when you're ready to build applications that you want to host on a server called Heroku, we'll use something else, a different version of SQL. Different versions of SQL allow databases to be interpreted in different ways. Some new languages of SQL allow you to put arrays in your database, right? We're going to kind of avoid that. We're just going to stick to some really basic data types that you can put in your database. So let's see, data types that SQLite 3 allows. Let's see what we have here. So SQLite 3 looks like, let's see. I don't know exactly what these are. Integer, text, real, blah, huh. I don't know if I've seen, this doesn't look great, but generally when we can, so SQLite does not have support, or does not have support. Oh, okay, so Boolean values are stored as 0 or 1. Okay, cool. So we have a limit to what kind of information we can store in our databases, right? So we can store null in our databases, we can store integers, we can store something called real, which when we're using Active Record as our ORM, I think these get translated a little bit. It handles putting stuff into SQL the way that SQL will allow, but as from the coder's perspective, it'll be a little more clean, it'll make a little bit more sense. And then of course we can put text. I'm not 100% sure what a blob is, but apparently we can put a blob in there too. But once we get into putting information into SQL databases, you'll see a little bit more what I'm talking about. But again, we're restricted to the kind of information that we can put in. So if you were working on your project and you were maybe you had an attribute that was an array or a hash, I may or Jen may have advised you to find a different way to handle this bit of information, because we were trying to introduce this concept that the attributes for your models should be really basic data types, because we want you to become familiar. What is actually possible to store in a database, right? You can't really store an array or a hash in a database. But again, we'll get into that a little bit more in a second. Okay, and then we'll dive into all of these here in a second. But I just wanted to go over one last thing really quick, which is what CRUD stands for. CRUD stands for create, read, update, and delete. And when you think about what you can do on basically any web application, any application in general, web applications, all websites are just really glorified, elaborate versions of these actions, right? We can create things, we can sign up and create accounts, we can upload photos, we can make posts, we can buy tickets, we can, make friendships, we can create likes, so it's basically this create action really drives a lot of our experience of interactivity in applications. With read, reading is recalling information. So when you log into an account and it says, oh, this is what you've looked at before, these are the people that you most talked to recently, here's your upcoming itinerary, right? These are reading things. We're pulling information from our database and we're showing it to the user, right? Update, of course, we've already created something in the database, but we want to change it a little bit. Maybe when we want to change our picture, maybe we want to change something in our itinerary. Maybe we want to update the caption to the photo, right? We've already created the caption to the photo. We can read the caption of the photo, but now we want to update the caption of the photo. And then finally, delete. We want to erase this from our database. We don't want its reference to exist any longer, right? So everything kind of comes down to CRUD. CRUD is a very important acronym to memorize. And then today during this exercise and moving forward, you should always kind of be asking yourself, which CRUD action is being performed here? Are we creating something? Are we reading something? Are we updating something? Or are we deleting something? So we'll get into that a little bit more. Are there any questions on any of these learning goals? At least preliminarily, I know again, we'll kind of go back and review these later. Once we've done some SQL queries, but any questions about SQL relational databases? No. Okay. All right, so if you haven't done so already, there is an application that we asked you to download called DB Browser for SQLite. And there are actually several kind of database browsers, and they really help you kind of visualize what your database looks like. So I wonder if I can, Jen, do you have a favorite database browser?
I was using the same one as that, and actually, I don't think I even have it on my computer anymore because I had too much space. I had to get rid of some things.
Totally. There are several of these. I think from a coder's perspective, you'll see once we get further along that our applications like, our active record applications that come with Sinatra and Rails will give you a file called a schema. And the schema will be pretty good at helping you visualize your database. But if it's helpful for you, you can look for a database browser and it will show you your relationships in a way. If you're a visual learner, I would encourage you to kind of do some research and see if you can find a database visualizer, and it will kind of put everything together like this for you. It'll say, okay, so here are these models and here are the columns and this is how they relate to each other. And then, you know, maybe if, I don't know, I don't think that your application will ever get this big. But it is kind of helpful to see how they relate if that's something that you're into.
I also, Chris, I just draw it out by hand.
Or yeah, you can draw it out by hand.
It's very different and probably not as effective as those, but.
Yeah, no, but that's a good practice for you because if you draw it out before and then compare it, visualizing databases and visualizing relationships isn't something that we're going to expect you to get right away. This is something that you should be asking Jen and I to do as exercises on your one-on-ones if you feel like you're a little bit shaky on the visualization of your databases. And we can go over this again in just a second. So, okay, so I have a database in here. It's called Chinook, which is a type of salmon, and I don't know why the person who created this guideline called it Chinook. But basically here we have a database with 1, 2, 3, 4. I don't know what these are. Honestly, I'm not 100% sure, but these are kind of the ones that we should be paying attention to. We have albums, we have artists, we have genres, and we have tracks. And again, we could think about how in a Ruby application, we should have classes for all of these. So again, in general, if you have information in your database, you're gonna have a Ruby, later down the line, you're gonna have a Ruby model. And once we get to ORMs at the end of the week, we'll demonstrate to you how the purpose of Ruby, an active record, which is an ORM, is to take the information in our databases and animate them into Ruby objects. But just to kind of help you with this kind of big step that we're taking, we're really kind of leaving Ruby behind for a day or two and just talking about databases, but to help you kind of visualize when these two things are going to come together. Again, your tables are basically the names of your models, and then the columns are mainly the attributes. So one thing that you'll see here for albums, for example, is that, well, all of these, in fact, are going to have an ID. And this is a primary key. If we were playing around in a Ruby application, oh, this little bar. If we were playing around in a Ruby application, for example, and I said, you know, if we make a new instance of something in Ruby, right, we're given this key, and this number basically is a reference to where this instance is living in the memory of our computer, right? And if I let's see, so you know, whenever I create a new dog, the numbers here are going to be different, right? And so far in our application, if you've ever needed to reference something, or if you had a relationship and you said like, I want to find all the songs that belong to this artist, you were basically comparing these two, you were basically comparing these numbers against each other, right? This Ruby instance lives in this place in my computer's memory. And in order for me to make sure that the reference is the same, I want to make sure that, you know, it's exact same number. This is basically the reference to the instance. Once we get to databases, this reference instance doesn't really matter, because now the information that we really care about lives in the database. So it would kind of be like saying, oops, let me think. So, I think it'll be good to kind of demonstrate with examples. So let me terminate this. So if we look at the data here, and if I look at all of my albums, you'll see that every album has a unique ID, right? So moving forward, if I, and notice, okay, yeah, so these are called primary keys. This is saying that this is ID number 1 of my albums, right? So whenever you create a new model and you create a new table in your database and you create your first instance, we of course just start at 0, right? And as we add more albums, the number is going to increment. This is called the primary key. This means that on the albums table, right, this album is album number 1, album number 2, album number 3, album number 4. This title and this ID are referencing the same instance, or the same what we would call row in the database. This artist ID column here is called the foreign key, because this ID references something on a different table, right? This is saying the artist to this album lives on the artist table, and it's ID number 1. So for those about to rock, We Salute You has an artist ID of 1. If we go to the artist table, the foreign key of the artist in the albums is the primary key in the artists table, right? So if I go back to albums and I say, okay, I really don't know a lot of these, but let's say, okay, so Chill Brazil is the 34th album, right? ID number 34 in the albums table, but the artist is number 6 on the artist table. So we go to artists and we go to number 6, it's saying, okay, this is Antonio Carlos, right? So that's the difference between the primary key, right, and the foreign key. The foreign key always tells us, go look somewhere else. To get the information that you want here, you have to go look at a different table, right? Okay, so a couple of things to note about the primary key. It's always an integer, of course, and it can never be replaced. The database keeps track of auto-incrementing the numbers for you. If you were to delete for those about to rock, We Salute You, ID number 1 would disappear and it would never come back again, right? It would never exist again. So if we were to clear, so for example, we have, in this database, we have 347 entries. If I were to delete all of these albums from the database and create a new album, the next number would be 348. It's a rule of databases to never reuse a primary ID, a primary key integer as an ID ever again. Because again, to kind of maintain structural integrity, if there is some sort of relationship in another part of your application or another part of the database that's referencing a number, and you replace that row with different information, if databases were to work that way, so if I deleted number 1 and then I put, again, Lemonade by Beyonce again, and if it were to go back to number 1, right, if our database were to reuse that number as a primary key, then all of the songs from AC/DC's For Those About to Rock We Salute You would now appear to be on Beyonce's Lemonade, right? And that's not accurate. Okay, what else? So define a primary key, define a foreign key. Okay, so are there any questions about the database structure here? How the table names reference or are going to mimic what the classes are called, what the models are called, and the columns are to will relate to what the attributes are. Any questions about that?
Could I ask you a question a little bit different? And feel free to not answer right now too. Okay. I do have this browser, and how do you get your information into that browser?
How do you get the information into the browser?
Like your table. Mm-hmm.
We're gonna do that right now.
Okay, great. Swell. Keep doing you.
Cool. So the only things that I wanted to kind of set the ground for here in this case are that we are creating tables. The tables again relate to the models. The columns in the table, right, relate to the attributes that we would have in the models. And a new thing that we're introducing is this ID, right? This integer primary key that auto increments the database keeps track of, that the database keeps track of for us. Any other questions? Okay. So I have this README here, and we're going to kind of go down through a few of these deliverables, and we're going to practice writing a few lines of SQL, just so that you guys can get an idea of how these things work. So of course, this database is already populated, but we're going to add another table, and we're going to add instances or rows to the table, so you can get an idea of how to populate this. And then maybe if we have time in the end, we can do something from scratch. And I always really like to do this because then you can see how something begins. Okay, so, and for those of you who have already reviewed some of the SQL and who maybe are familiar with some of these queries, feel free to jump in. I'm going to ask to see if anybody knows already. And if not, then I can kind of demonstrate how to do this. So the first challenge that we have here is write the code of SQL that will return all of the rows in the artists table. Has anyone who's done this so far, or who has practiced SQL so far, know how to write this code? And you can feel free to plop it in the chat if you know it. Okay, great, Nelson. So Nelson says, select star from artists. Okay, Nelson, can you tell me why you decided to make some of these letters capitalized and some of them lowercase? Thank you.
So SQL read the capital letters as it's like if you're putting in a command. I can't explain it well, but it's like that's what SQL reads, like the capital ones, so it knows what it's doing, and then all the lowercase ones are like the table or the attribute you're trying to refer to.
Great. I actually think that SQL could read these without them being capitalized, but it's a way for the engineers to separate the difference between what are the keywords of SQL, and then what are the variables that we've created, right? So all the capital letters are keywords from SQL that are supposed to be performing an action or directing SQL which action to take, and the lowercase words are what was I saying? The lowercase words are the variables that we've created. Or so we can go into this execute SQL section here in the DB browser, and we can paste or type in lines of SQL that will query the database, and then we can see the results here. So the star, by the way, means everything. That means give me all of the attributes. We could also otherwise separate the information that we want. So if we wanted, just give me the IDs from the artists table, we could do this, right? You'll see down here that we're just getting a list of the IDs. Or we could get all of the names, right? Give me all the names from the artist table. So the word that comes in between select and from is the column, right? That we want information from, or the column of information that we want, and the from comes from which table we want it from. So sorry, that's a little bit confusing, but I'll write a note here. So the first thing to notice is that the keywords are capitalized, the SQL keywords are capitalized, and the lowercase words are the variables the coder creates. So this will be like the table names, column name. Okay. And let me see if this would still work. I just want to double check. Yeah. So it still works, but it's what we call convention, right? The convention is to capitalize let's see. The convention is that SQL keywords are capitalized and the lowercase words are the variables that the coder creates. Okay. Now, which part of CRUD is this? When I'm selecting all of the information from the artist table, all of the columns from the artist table, am I creating something? Am I reading something? Am I updating something? Or am I deleting something? Let's see. Yep, I'm reading it, right? I'm pulling information from the database. One other thing that I wanted to note is that we can also use commas here to separate or to get multiple information of columns. But this isn't a great example because there are only two here. So if I were to go, for example, to my tracks, and I said, give me the name and the composer from the tracks, I can say, give me name, composer from tracks. Here we go. I get the name and the composer. This obviously isn't everything, right? It's not star. Star means everything. Right, now we get everything. We can do one, we can do multiple, and of course we can change these. What was another one? Bytes? I think so, yeah. Cool. Yeah, just a little demo of what's possible. Okay, so we wrote our first line of code that's a read action in SQL, right? Are there any questions so far? What if you only want the name of like ID 12 through 20? Okay, let's maybe practice that one at the end if we have time, but of course this is possible as well. We can set a range, right? We can say, well, I only want the artists that are between these two IDs. This is possible too. The next one that we'll do is write the SQL to select the artists with the name Black Sabbath. Does anybody want to take a stab at how to write this code? Okay, Nathalbert. Nathalbert says, I'll just copy and paste it here. Select star from the table artists where the name equals Black Sabbath. Let's give this a try. Oops. No such table artist. Okay. So remember, oh, this is a very important distinction to make. And I'll put this, let's see where I'll put this. So maybe I'll just put this here. Where should I put this? I'll just say like a note. Ruby models are always singular. Table names are plural. So this is kind of one of the tricky but important things to remember moving forward. Whenever we're building Ruby models, Ruby classes, of course, the name is always singular: artist, song, genre, etc. But when we're making tables, our database should always be plural. Our table name should be plural: albums, artists, genres, tracks. Okay. So Nathelbert had the right one here. So select is again the Ruby keyword that says, go grab all this information for me. Star means I want the information from every column. From is followed by the table where we want to get this information. And then with the keyword where, we're setting up a parameter, right? I only want the artists where the name is equal to Black Sabbath. Let's see, I have a message in the chat. Okay, cool. Thanks, Lucy, for putting that in there. Notice here too, kind of a tricky thing that's important to remember is that SQL is not using the double equals. We're used to the single equals setting a variable name, but in the case of SQL, the single equals is a comparison. Okay. What CRUD action is this? What kind of CRUD action are we doing here? Are we creating, reading, updating, or deleting? Yep, we're also reading here as well. All right. Our third challenge here is we're going to write the SQL to create a table, and that table is going to be called fans. And the fans table is going to have a few attributes, right? The fan table is going to have a column with an auto-incrementing ID. That's going to be the primary key, and a name field and column named, a column titled name. And the type of data that we are going to be allowed to put into this column is text. Does anyone think they can give this a shot? Well, yeah, Brandon, thank you. This CRUD action is create. Of course, we're creating something. Well, yes. Yes. It's a little bit tricky because there's kind of two levels of CRUD, right? There's CRUD on the level of adding rows to the database, but then there's CRUD on the level of adding a table to the database. It's a little bizarre, but yes, this is, I guess, technically create. All right, Nathelbert coming through with the examples today. Oh, same with Lucy. Okay. I think you all came up with very similar answers. Perfect. Thanks, Lucy. It's exactly right. Okay, so the line of SQL that we have here says create table. So notice that the first word no longer is select. We're changing the initial action of what we want our SQL code to do. SQL is no longer selecting information from columns and rows from a table. It's in fact creating a new table. We're saying, I want to create a new table and I'm going to give it a name. Again, it's plural, right? And then, yes, yeah, I was just about to say that. So after we say create the table fans, we basically put parentheses, and this begins what we would be familiar with as kind of giving arguments, right? We want to create a table fans, and we're going to pass in the arguments of I don't think we need to put auto increment here. We're going to put in the arguments of what we need. So the sorry, primary key is responsible for, yeah, exactly. Primary key, so sorry, I'm like talking in the chat, but I'm responding to the chat, but also talking to you all. So the So the arguments here are separated by commas, right? The first word is going to be the name of the column. And SQL always knows that it's going to be a first word. If this were something longer, for instance, like if we wanted this to say, you know, I don't know, this is not random, but like, or this is random, but sort of over here, for example, we could say like dog's name, or I don't know. Basically what I'm trying to communicate is that if the column were to be several words, for example, we would use what's called snake case to give that column a name. So, you know, favorite color or something. So what I'm trying to communicate here is that when we're providing arguments to this, basically this kind of function for the SQL query, the first word is always going to be considered the column name because it's never going to be separated by spaces. Notice here, however, that the words that follow are separated by spaces and they're SQL keywords. So SQL will know how to interpret and read these words. Again, your column names should always be if column names are more than one word, use snake case. Okay, so we want every row in this database to have an ID. This should be an imperative. This should be something that we always expect to do, right? We always want to be able to, we always want our, the rows in our database to have primary keys. When we say primary key integer, we're telling SQLite, these are supposed to be unique numbers and they should never be reused. So once we use ID number 1, never again in the future of this table can the ID 1 ever be used. Primary key integer are also the 3 keywords when put together creates that auto increment for us. So we don't have to do the auto increment. And then again here, I think that the column name is text. So if we plug this in, we can look at our database structure. We see that we have albums, artists, genres, and tracks, but we don't have a fans table, right? We want to add a fans table. So I can execute the SQL here to create a new table called fans with an ID of primary key integer and the name of text, or and the name with text. And I'll run this. Oops, integer. Oh, is it just primary key? Let's see. There we go. Okay, I guess it's just primary key. We don't need integer. And if we look at our database now, I have a fans table and it's got an ID and a name. And if you see this little lock here, that's SQL kind of confirming like, hey, I'm in charge of I'm in charge of this. Wait, what does it say? ID text. Integer primary key auto increment. Maybe it does need to be auto increment. Jen, do you know?
I think Brandon just put it in there. I think the integer was just in the wrong spot.
Integer primary key. Cool, got it. Okay, so let me drop. So if we want to practice dropping a table, we can say drop table fans. This will get rid of the fans table for us. And then I can try this again. There we go. And fans, here we go. It still doesn't integer primary key auto increment. Let's see, I think this should work. We're gonna, in the next one, we're gonna create a fan. So we'll make sure that this works. Write the SQL to alter the fans table to have an artist ID column type integer. Oh, okay, so we'll do this. Well, that'll be number 5. Write the SQL to alter the fans table to have an artist ID column type integer. So in the case of the way we're building this application, every fan would only be able to be the fan of one artist, which isn't realistic, but we're just practicing SQL queries here. Does anyone want to give this one a shot? Write the SQL to alter the fans table to have an artist ID column type integer. Oops. Okay. Sweet. I think this needs to say add column, but alter table fans. Oh, I might have to look this up. Alter table, add column. Yeah. Alter table name. Oh, it is just add. Okay, cool. You're right. Sorry for doubting you. Alter table fans, add artist ID, integer. Alrighty. Cool. So now if we look at our fans table, we have a new column. It's an artist ID, and it's got an integer. Sweet. All right, and what version, what part of CRUD is this, so to speak? Totally, we're updating something here. Again, this isn't always 100% how you're gonna experience CRUD, but it's cool to start thinking about things in this way. Are we creating something? Are we reading something? Are we updating something? Are we deleting something? Okay, and this will be the last one that we do, just because we have a few minutes left. And there are a couple more things that I wanna go over with you. So write the SQL to add yourself as a fan of the Black Eyed Peas, which is artist ID number 169. Does anyone want to give this one a try? Any takers? Ah, great. Thanks, Brandon. Okay. So, oh, but you're missing one thing. This is what Brandon wrote, but he's missing one thing. So the keyword, the SQL keywords for adding a row into a table is insert into, right? Insert into, and then we specify the table name. We're inserting some information into the fans table. And then the argument here is to put the information of the two columns or any of the columns that you want to put information inside. So yes, we want to put information in the name column, but as Nelson also pointed out, we also want to put information in the artist ID column, right? And then over here in the values, we have to correspond with or put our arguments in the same order. So Brandon, I'm putting you in. And remember that the name column is a text column, also known as a string column, right? When you see text in Ruby terms, it's a string, but in database terms, it's text, depending on which SQL language you're using. And then the artist ID is an integer, so we're going to put 169 here. Again, we're inserting into the table fans some information that are going to go in these these two columns, name and artist ID. And then the information that we're going to put is Brandon, that's the name, and the artist ID is 169. Let's run this code. Cool. So it says query executed successfully. Took 0 milliseconds, 1 row affected. Let's go look at this now. So if I click on browse data and I go look at my fans, we see that we have Brandon, who is our first fan. So his ID is number 1 and the artist ID is 169. Again, so is this the primary key or the foreign key? Great. This is the primary key because on the fans table, Brandon is ID number 1, right? This is the foreign key because 169 has nothing to do with fans, right? We're saying, oh, if you want to go figure out which artist Brandon is a fan of, you have to go check out the artist table at 169, right? Okay, cool. So this is just a little taste of what SQL is like. Tomorrow during the study group, we're going to dive deeper into more complex SQL queries and putting more information into databases. But I just wanted to get you familiar with what the language of databases is like and how we can execute them in real time. Now, so far in this moment, we are using this kind of middleman, right? We're using DB browser to execute our SQL for us. But what we're also going to learn by the end of the week is how can we get Ruby to execute SQL for us? How can we get Ruby to, how can we pass lines of code of SQL to Ruby and have Ruby affect the databases, right? So one little step that I just wanted to show you before I let you all go is it's actually very simple to create databases with Ruby. In fact, the only thing that you need is this gem called SQLite 3. So in my gem file, I included SQLite 3 here. I ran bundle install. In this how to database file, I just require SQLite 3. I'm also requiring Pry so I can give you a demo. And SQLite 3, right, has a module called database, which has an instance, or sorry, a class method called new. And we just pass in the directory of a file that we want to become our database. And it's as simple as creating a new file, saying new.db, not putting anything in it. This is a blank file, right? But Ruby will know to say, okay, I'm gonna go to this directory, take this file, and I'm gonna start writing my database information in there. If we go take a peek at the chinook.db file that we had just created, or that we were just working with, you'll see that this is just kind of like full of nonsense. If you look in here, you can kind of see a little bit of how SQLite is keeping track of how the tables are composed. And then of course in here too, we have a bunch of our data, right? All of our data is living in here. Although it's not completely perceptible to a text editor, right? Our DB browser can interpret this information. So I'm just actually going to go into my, I'm going to go in here. Let's see. Oops. And I'm going to run my how to database.rb file. And I hit this binding.pry. So when I look at DB, I see that a new instance of a database has been connected, right? This is a Ruby instance, but SQLite 3 is a gem. And so there's kind of a bit of, right, there's a bunch of stuff going on behind the scenes that the gem SQLite is handling for us. But basically we have this instance of a database with a bunch of methods, right? If we type db.methods, we can see all of the possible things that we can call on this instance. One thing that we can call on this instance, let me see if I can find it. I always forget what it is off the top of my head. Isn't it just SQL? db.sql? It's execute. Okay. So let's go back, for example, to this README, and let's take my create table fans, right? So on my database, I can call execute on it, and I can pass it. Jen, I'm sorry, do you remember if I have to put it in quotes? I don't remember it off the top of my head.
I think, but I don't remember, to be very honest.
No, okay.
Okay, that was wrong.
No, I think you have to do something like, hold on, someone said something in the chat. I can look it up really quick as well. Primary quotes, yeah, but.
Oh, but your last one, I think you were missing a parenthesis.
Oh, here. There we go. Okay, great. Thank you. Okay, so I just took this DB instance, right, from my how to database, and I called a function on it called execute, and then I passed it a string of SQL code, right? And now if I go look at my new.db file, there's some information in here. A table has been created, right? So Ruby, in this case, SQLite is a gem that works with Ruby and has provided a method that allows us to execute our code here. I can continue on and say, okay, so now I want to, add Brandon. Although I don't have an artist's table, you'll still kind of see what I mean. So, right, I'll still have this foreign key that won't reference anything. But I just kind of want you guys to get a, oops, what did I do? Oops, there, oh no, what did I do? Values Brandon 169, hold on, people are helping me. Let's see, I don't think you need that. Insert into fans, values Brandon 169, but I think I need this. Unexpected end of input, unexpected. Let's see. Why isn't this working? Do I need this? No, I don't think I need that. Into fans name, values, Brandon, 169.
Hey, Chris, I think it's good, the quotes. Try using single quotes for Brandon.
Oh, yeah, thank you. Oh, table fan says no call. Oh, because I forgot to execute this first. Wham, 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 wham. Okay, 1 second. Thank you. I have to execute this first. And I know we're just at time. This is the last thing that I really wanted to show you, so it's good. Oops, no. Okay. And then I do this. Okay, awesome. And then if I were to, so I've created a table of fans. I've added the artist ID integer. And then if I were to say select all from fans, I would get back an array of the objects in my column, right? And then if I were to go into my DB browser and open up the database for my intro to SQL that I just created, I can browse the data and see that I have one table of fans with an ID of Brandon. So as we move throughout the week, you'll start to see how we can use this SQLite 3 gem and the methods therein provided to start taking the Ruby models and classes that you have created and make them resemble or interact with our databases. Okay, that's it. Thank you so much for coming. I'm really excited to dive into this further with you all. I hope this was helpful. Again, I'll put all of the information, all of this code will be uploaded